Hello and good morning to all of you. I hope all of you are doing well. So in today's class, we're going to learn about software reverse engineering. So reverse engineering, as we have learned in the previous class, is a mechanism of extracting the design and the specification document from the code. And we have also learned the reason why we need reverse engineering. So we have seen that reverse engineering is required in situation where the necessary artifacts associated with software systems are not available, and even if it's available, if it's not usable, so we need reverse engineering. We need reverse engineering if the documentation is not proper, and we need reverse engineering if the software engineering principles are not properly adhered to. So now, in order to carry out reverse engineering, first what we need to do is we need to bring about some kind of fabrication or some kind of cosmetic changes to the code. So cosmetic changes are brought about to the code in order to ensure that the code is readable, because only if the code is readable it is understandable, only if it's understandable it's acceptable, and only if it's acceptable it's maintainable. So just see, these are the qualities that are related to one another. So what we need to do is we need to bring about cosmetic change in order to ensure the code is readable, structure is properly maintained, and understandability is enhanced. So what we need to do is we need to reformat the program. Okay, we need to neatly arrange the structure of the various structures that are there in the program, or the layout of the program. What we need to do is we need to give meaningful name to the variables, data structures, and functions. And what we need to do is we need to replace complex and nested conditions with simple conditional statements. So that is the way how what we can do is we can bring about cosmetic change. Again, we'll repeat it. So in order to enhance the readability of the software application, what we need to do is we need to bring about cosmetic change. So cosmetic changes are brought about in order to make this code readable, the structures stable, and the program much more understandable. What we'll do is we'll reformat the program by changing the layout of the entire program, by giving meaningful name to the variables, functions, and data structure, and by replacing complex and nested conditional statements with simpler conditional statements. So this is the process, right? Okay. So what we need to do is we need to reformat the program, assign meaningful name, then simplify condition, replace goto, simplify processing. So here replace goto is explicitly placed because you know that goto statement causes the program to be unstructured. Now there are three fundamental principles of structured programming. The fundamental principles of structured programming are these are sequence, selection, and iteration. So if any of these three are violated, either sequence or selection or iteration is violated, so what we do have is we have unstructured programming. So unstructured program. So in order to overcome that, what we need to do is we need to remove any construct that causes the program to be unstructured. So that's why it's written replace goto. So what we need to do is we need to reformat the program, assign meaningful name, simplify condition, remove any construct that causes unstructuring, and simplify processing. Now let us talk about the various maintenance models. So we have two maintenance models, maintenance model 1 and maintenance model 2. So maintenance model 1 is a maintenance model that is purely dedicated for maintaining software system with which all the necessary artifacts are present in a very sound and a usable condition. And maintenance model 2 is a maintenance model that is purely dedicated to maintaining software system with which the necessary artifacts are not available or are not in usable form. So what we need to do is we need to extract the design and the specification document from the code, and then what we need to do is we need to carry out maintenance. So here what we have is we have reverse engineering. So that is the major difference between maintenance model 1 and maintenance model 2. So maintenance model 2 only has forward engineering, whereas maintenance model 2 has reverse engineering as well as forward engineering. So let us try to understand each of these maintenance models. So in order to bring about a change in software application, what we need is we need maintenance, as we've learned about. So when the requirement changes are small and simple, the code can be directly modified. Changes can be easily reflected to the necessary documents, and more elaborate activities are required when the requirements are not trivial. So this is very much true, right? Again, so whenever we are trying to bring about simple changes, so it may be very easy to manipulate the code or bring about small changes in the program. time, and changes may be reflected to all the necessary documents, right? That may be there, maybe in SRS document, design document, or the code itself, the test documents, and so forth. But in situation where the changes are non-trivial, or the expectation of the customers are complex in nature, so what we need to do is we need to carry out a strict a sequence of steps that are to be executed for performing maintenance, right? So first, what we need to do is we need to start by gathering change requirements. So we need to identify what are the changes that are called upon by the customer by the customer. Then what we need to do is we need to analyze the change requirement, formulate strategy for code change, because you see. There might be various kinds of requirements that the customers may demand or may call for whenever maintenance carry out. But it's very important for us to analyze the change requirement, because until unless we do not analyze the change requirement, we will not be able to understand how the change requirement incorporates to the existing software. So that is very much important. So first, what we need to do is we need to gather the change requirement. We need to analyze the change requirement and formulate code change strategy. So how we are going to change the code? Now, once the code change strategy has been formulated, so what we need to do is we need to ensure that the code change strategy is capable of incorporating changes into the software system in a seamless and a smooth manner. So what we need to do is we need to ensure that we select appropriate appropriate labor force for bringing about a change in the bring about a change in the software application. So what we need to do is we need to have presence of few members of the original development team. So this is very much important, because until and unless we do not have members from the original development team, it may so happen that it may be difficult for one to understand the software application, and further to maintain the software application. So what does it help in? It helps in reducing the cycle time or the maintenance time, and especially for unstructured and inadequate document code. So in situation where the code is presented in a complex manner, so what we need to have is we need to have participation from the original development team. So just see, in order to carry out maintenance, you need to focus on various aspects. You need to focus on not only the change that is to be brought about, but you need to focus on the quality of the skilled labor force or that you have, right? So you need to have member from the original development the team that is capable of at ease contributing to the maintenance process. Now, availability of the working, you see here, availability of the working old system at the maintenance site, it greatly helps the maintenance team in order to understand the software system, right? So it provides a good insight into the working of the old system. So as I've said, if there's the old system existing in the deployment site, then it will be very easy for the maintenance engineer to understand what it's capable of doing, and it will be very easy for the maintenance engineer to analyze the requirements as well, right? Again, and further to impose the changes that are to be incorporated in the software system. And so it becomes very easy for the maintenance team to have a comparative measure of the existing software system and the new or the modified version of the software system, right? Now just see, this is the way how the maintenance model one is executed. So gather change requirement, analyze change requirement, devise code change strategy, apply code change strategy, update document, and integrate and test. So these are the sequence of steps that are followed. So first, what we need to do is we need to gather the change requirement, we need to analyze the change requirement, we need to devise code change strategy, we need to apply code change strategy, and we need to update and the necessary documents and integrate and test. So let us again go through a software maintenance model one. So whenever we are trying to maintain a software system, as I've said earlier as well, we can adapt to either of these two maintenance models. So you can go for maintenance model one, or you can go for maintenance model two. But maintenance model one is well suited for a system where the documents or the artifacts that are necessary for maintaining are readily available, right? Again, so here maintenance model one can be used for maintaining a very simple system, or maybe capable of it's also capable of bringing about maintenance work in a complex system. Whenever you're trying to maintain a very simple system, then the code may be easily modified and the documents may be easily updated. But whenever we're trying to maintain a complex system, we need to follow a well-defined sequence of steps, where what we need to do is we need to identify the change requirement, we need to analyze the requirement, we need to devise the code change strategy. And whenever we are trying to devise code change strategy, we need to ensure that some of the members of the development team is part of the maintenance team, right? Some of the members of the development team is part of the maintenance team. It does not only reduce the cycle time, but it also helps us in understanding the code better, right? Again, now availability of the old system in the deployment side also helps in carrying out maintenance work with relative ease, because it helps in understanding the existing system, and it helps in devising a mechanism for evaluating the performance of the new system. Now we have learned about the maintenance models, maintenance model one. So we have gather change requirement, we have analyze change requirement, we have device code change strategy, then we have apply code change strategy, then we have update document, and then we have integrate and test. Right. So these are the steps that are involved in maintenance model one. So now let us discuss about maintenance model two. Now maintenance model two is a maintenance model that is often used for software system for which the necessary artifacts are not available. So what we need to do is we need to regenerate the artifacts from the code. So we need to bring about cosmetic change to the code, and then we need to regenerate the design document and the specification document, and then we need to move on with forward engineering. So here for complex maintenance projects, what we need is we need a re-engineering model that is capable of supporting reverse engineering as well as forward engineering. So a reverse engineering cycle is followed by forward engineering cycle in case of maintenance model 2. So here, in this case, what we are trying to do is we are trying to generate the design and the specification from the code, and then we bring about a change to the design and the code and the design and the specification, and then reformat the code and bring about a change in the code. Right? Again, so it's preferred when amount of work is significant, software has poor structure and poor documentation. So just see, we have learned about what is reverse engineering, so we'll not be going through it in detail, right? So during reverse engineering, the code is analyzed to extract module specification and the design document, right? The module specifications are analyzed to produce the design document. The design is analyzed in order to produce original specification document. So that is the way how it actually works. So let us so here what we have done is we have highlighted few of the advantages of re-engineering as well. So better understanding of the product. So better design can be the product design can be understood, right? What we can do is we can bring about the information about the requirements that we implemented, right? It often results in high efficiency because it's capable of enabling one to understand better about the system that's to be maintained. So here, what we'll do is we'll straight away move to the model. So here what we have is we have reverse engineering first, followed by forward engineering. So from code we generate design. From design we generate the requirement specification, and then once the requirement specification is generated, then we identify the change requirement, incorporate into the existing requirement specification document in order to create new requirement specification. Then you carry out design and then code. So that is the way how maintenance model 2 basically works. So it basically starts with reverse engineering phase and forward engineering phase, followed by forward engineering phase. In reverse engineering, from the code we extract the design, and then we extract the requirement specification, where the requirement specification is altered in order to create new requirement specification, and design is carried out further code. So this is maintenance model 2. So as I've often said, maintenance model 2 is used for a maintaining system for which the necessary artifacts may not be available or may be available in situation in which it cannot be used. So just see here, what I need you to understand is I need you to understand this particular aspect. So reverse engineering or re-engineering is preferred where amount of rework is very high, product exhibits high failure rate, and product is difficult to understand. So this is a very important aspect that you need to remember, or you need to know why when to apply re-engineering or reverse engineering, right? Okay, so here just see, it's also stated that the total amount of effort that is dedicated in case of maintenance model 2 is definitely more than that of maintenance model 1, because we need to carry out reverse engineering. So in today's class, what we have learned about is, we have learned about what is reverse engineering. We've learned about what is the need for reverse engineering, right? We've learned about what are the steps that are performed whenever you are whenever you are eyeing to perform reverse engineering. So, how can we enhance readability, improve structure, and improve understandability? So, remove reformatting of the code, assigning meaningful name, then replacing complex and nested conditions with simple conditions, right? Okay, so then we looked into the various steps that are executed for refining the code, so that the code becomes rather understandable. Then we discussed about maintenance model 1 and maintenance model 2. So where in maintenance model 1 we discussed about when to apply maintenance model 1, and we have learned about what are the characteristics of maintenance model 1, and we have learned about what are the various steps in maintenance model 1. Okay, we have learned that a maintenance model 1 has following steps, where we gather requirement, analyze requirement, devise code change strategy, apply code change strategy, and then update, document, and integrate and test. So likewise, we have maintenance model 2. We learned about the implications of maintenance model 2. We've learned about reverse engineering in case of maintenance model 2. We've learned about its advantages, and we've learned about when to use re-engineering, right? And we've learned that there is substantial increase in the effort in case of maintenance model 2 compared to that of maintenance model 1. So it's almost exceeding by 15%. And then what we try to do is we try to understand maintenance model 2, where we have reverse engineering from in where from code we generate design, and then we generate specification. So once the specification is generated, then we bring about a change of the specification and create a new specification, further move on with design and code, right? So this ends the maintenance chapter. So thank you very much, have a very good day.